Class, welcome to our next video on 6-5. We're changing from the properties of special parallelograms to conditions for special parallelograms, and that is just a fancy way of saying that we're changing from if parallelogram, then blank property, to if blank condition, then parallel, or then special parallelogram, excuse me, sorry. Okay, so similarly to what we did back in 6-2 and 6-3, where we first started by saying if p-gram, then blank, and then we switched to if blank, then p-gram. All right, so we're just flip-flopping. Just like 6-2 to 6-3, now same thing between 6-4 and 6-5. All right, so this is just a review. We already probably know these properties and conditions. We just have to kind of see what they look like. So we know that we have a parallelogram, and if one angle is a right angle, what do you think that tells us? That's actually going to tell us that we have a rectangle. And we know that because if this is a parallelogram and this angle is a right angle, well, opposite angles are congruent, so this would have to be a right angle, and consecutive angles have to be supplementary, so this is a right angle, right? So you really only need one right angle to prove that they're all right angles. Again, if it's already a parallelogram. All right? Well, we also know if the diagonals, right, we're seeing here AC, BD, if they're congruent. Well, we learned that yesterday, right? We put that on our big organizer. If you remember, right here, we put that right down here. Then the parallelogram is a rectangle. So there our conditions are our conditions for rectangles, and now we need to take care of the ones for rhombuses, and then we will get to a little bit of practice. Hopefully it won't be too much, okay? Okay. So, what we know here in this picture, we see we have a parallelogram, and I'm actually seeing that EH and EF are congruent. So I'm going to call those consecutive sides. Just like we have consecutive angles like E and F or E and H, well, we can also have consecutive sides, sides that are directly next to each other, not opposite. And if we know that consecutive sides of a parallelogram are congruent, well, then we know we have a rhombus. And again, hopefully you agree with me, if this is already a parallelogram, then we know that if this is a single tick mark, well, across from it has to be a single tick mark. And if this is a single tick mark, well, across from it has to be a single tick mark. And then all four sides are congruent. Okay? The one right here in the middle, we know that if we see lines that are perpendicular, right? And how do we know they're perpendicular? Because of that right angle symbol. So if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Rhombus. Okay. And lastly, we notice that this diagonal of the parallelogram is bisecting this angle at F and at H, and F and H are called opposite angles. So if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. All right? So guys, all of this stuff we can see on our big organizer. All right? We know that opposite angles are bisected for rhombuses because of the picture that we drew. All right, everything that you need is on your big organizer, so I strongly encourage you to continue to use your big organizer. As we flip to page 38, and we read the instructions, because this is absolutely something that you're going to see again, I want you to tell whether each quadrilateral is a parallelogram, rectangle, rhombus, or square. And I'm going to change this. I'm going to say and or square. Okay, and what I mean by that is I want you to basically go through a checklist. Every single shape, I want you to decide, is it a parallelogram? Is it a rectangle? Is it a rhombus? Is it a square? So when we look at number 1, I see that I have one set of opposite sides that are both congruent and parallel. That is a property or a condition for parallelograms. So I would list parallelogram. Now I would go down the list. Rectangle. Well, do I see diagonals that are congruent? Do I see right angles? No, I do not see any condition for rectangle, so I would not write the word rectangle. And just so that I know some of you guys watch this on mute, so I'm going to actually put a line through rectangle so you know that it is not a rectangle. Let's check for rhombus now. Well, let's see. We already knew it was a parallelogram, but to become a rhombus we need to have all four sides congruent, or diagonals perpendicular, or diagonals that bisect opposite angles. Nope, I don't have anything, so I can't put rhombus. Now square's the easiest. Square's the absolute easiest. We know what. Squares occur when you have both a rectangle and a rhombus, and because both rectangle and rhombus are crossed off, it's not a square. And so now I would know that this shape, the most specific name for this shape is a parallelogram. Okay? Let's check out the next one. Very similarly, I again see a condition for parallelogram. Where? Well, I see opposite sides that are both congruent and parallel. So this is again a parallelogram. Now, let's check for rectangles. Again, with rectangle, we're looking for either congruent diagonals or right angles in the corners. And let's see here. Ooh, I see a right angle. And if this is a right angle, then this is a right angle. So they're all right angles. So yes, this is a rectangle. I will not cross off rectangle this time. Let's check out rhombus. Again, for rhombus, and you know what? I should be doing this a little more. I'm sorry. For rhombus, I know that I either need four consecutive or four congruent sides, or diagonals that bisect opposite angles, or I need perpendicular diagonals. So when we look, ooh, I see this right angle right in the middle. Yes, this is a rhombus. Why? Because perpendicular diagonals. Okay, and actually I should put right here, one right angle means four right angles. Okay? And lastly, let's check for square. Well, the only thing we have to do is understand that squares occur when you have both a rectangle and a rhombus. And what do we have? Oh yes, we do. So square is good, both rect and rhombus. And so now the last question, and it didn't ask this here, because it does say to give all names that apply, so I would want you to list all of them. But if I changed the question and I asked you, give the most specific name, well, the most specific name for this object would be a square. Alright, so that's why I'm circling it, just to let you know that that would be the most specific name. Alright, let's take a look at this next one, or next couple, and then we will call it a day. Alright, so for number 3. Number 3, we have to do a little bit of work first. Okay, so I'm going to start by seeing if we have a parallelogram. Parallelogram. So be really careful, guys. I don't have anything about opposite sides. I do have some stuff about opposite angles, okay? And I know it's a little tricky, but if these are double arcs and these are double arcs, well, what happens when I add these two together and these two together? These opposite angles are going to be congruent. Same thing with the others. So yes, this is a parallelogram because op angles are congruent. Now, is it a rectangle? Let's check. Do we have congruent diagonals, or do we have 4 right angles? No, I don't see right angles. I don't see anything about the diagonals being congruent. This is not a rectangle. Let's check rhombus. We know that rhombuses need to either have all sides congruent, diagonals perpendicular, or that the opposite angles are bisected by a diagonal, and that is what I'm seeing, right? Congruent, 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 congruent. Yep, This is a rhombus because op angles bisected by diagonal. So we're good on a rhombus. For square, again, what has to be true? You have to have both properties of rectangles and rhombuses. And while we do have properties of rhombuses, we do not have the properties of a rectangle, so square is no good. And of course, if I changed the question and I asked you to give me the most specific name rather than all the names, you would tell me rhombus. All right, last one. Let's check for parallelograms first. Parallelograms, we know we're looking at opposite sides, opposite angles, stuff like that. What can we say about these opposite angles and these opposite angles? Are they congruent? Are these two congruent? Absolutely. This is a parallelogram because op angles are congruent. Let's go to rectangle. Rectangle, this could be a little tricky. We need to remember what this means. If all four of the angles are the exact same arc mark, and a quadrilateral has 360 degrees, well then we can do 360 divided by 4 equals 90 to say that we can actually change these symbols, or just write 90, 90, 90, 90. And isn't that a property of rectangles? Having right angles? Yes. So 4 right angles. This is a rectangle. How about rhombus? Think about this one. We either need all sides congruent or diagonal. Well, there are no diagonals in this, so we know nothing about diagonals. So really, are all the four sides congruent? Oh, maybe, but there's no markings, okay? So we don't have enough information, so we cannot say that it is a rhombus. And lastly, square. Can this be a square? No, it cannot, because it is not both a rectangle and a rhombus. So I put a line through it, and I would say, again, if I changed the question, that rectangle is the most specific name. So, these were 4 really good examples. I want you to understand, on a quiz or a test, I do not need to see the reasons. Okay? I don't. I put the reasons here for the last few because I think, or I'm hoping it was helpful for you to kind of see where I was looking at to get the properties and to kind of prove that it was each shape. On a quiz or a test, I just need the names. Okay? But again, this is not a bad idea. This is really good practice if you can start to write out all the different properties and conditions that you see. Okay? So that was our 6.5 video. We will practice 6.5 more in class tomorrow. Have a great day.